As Fernando said, my name's Gerris. I'm a consulting systems engineer and I'm working with the data center and virtualization team in Europe. And today's presentation is really, as Fernando suggested, an effort to bring you up to date, to some level anyways, to some degree, with the infrastructure pieces that make up our cloud story today, as far as Cisco's data center infrastructure is concerned. And what does that mean? From a Cisco perspective, that does mean, when I talk about infrastructure, I talk about all of our switching and routing platforms in a data center perspective. So that's Nexus, by and large. But of course, we need to also be mindful of the storage network environment. We have a very rich, very good history with storage networking. Earlier on, you heard that we don't actually make storage. We don't, but we make storage networking products. So we also work very, very closely with our Tier 1, Tier 2 storage partners, EMC, NetApp, HDS, et cetera, HP, to name just a few. So we have a very good understanding of that. And that's important as I go forward through this discussion, because we're starting to see the convergence of networking as well as the convergence of other things. So that's a big discussion that's going around at the moment. So there I'm talking about things like fiber channel over Ethernet, for example. And I'll finish up the discussion with our unified computing system platform, an overview of what that is. So I'm guessing that really the drive towards some of the infrastructure changes we've made over the last few years are being driven by the need for 10 gig, certainly at the edge, but also down at the aggregation and core layer. If there's a need for 10 gig at the edge, is it just for speeds for the servers, for the virtualized environments, or is it for some other reasons, for consolidation purposes? And that's really where 10 gig comes in, and that's where fiber channel over Ethernet with 10 gig comes into the story as well. So yes, we've seen the advancements in CPU architecture, technologies, multi-core chips, making more of the server than was done before. So the capability to put more workload through a server generally means you're going to drive more I/O at the back of that PCI card or mezzanine card, whatever the type of server it may be. For that reason, therefore, we need to have 10 gig and looking forward to 40 gig and 100 gig capabilities in the network. And when organizations deploy servers and network, the experience I've had with customers that are talking to me about the next generation data center that they're trying to deploy, maybe the servers will change within 3 years, but the network may be in for longer. They want to make sure they're not going down some blind alley, so they want to make sure that they're investing in a technology that can be scaled, that can be upgraded, and can fit the network demands of the future as we go into this virtualized environment and the cloud technologies that were mentioned earlier. So yes, there's a drive being driven from a virtualized, a hypervisor environment to make more use of the CPUs, and make more use of the servers. Therefore, it's going to drive the I/O up on the server blades. We're also starting to see not just 10 gig LAN on motherboard on the servers. You've got 10 gig anyway, why not use it? But now we're starting to see the integration of 10 gig LAN on motherboard with FCOE capability built in. It's there already, whether you license it to do, maybe some server vendors will give that away. So it's there, you could wire it once, maybe you're not a fiber channel over Ethernet user today, but it's there already. You can cable it once and maybe use it later on. So that's the drive, as I see it, for some of the infrastructure that we've got ready and has been ready for some time as far as Cisco's infrastructure model sits. So you're seeing on the screen in front of you, yeah, lots of pictures of the family, right? So there's lots of products there. I'm going to go through some of them today. Obviously, some of them you could talk an hour about just some of the features on some of the platforms. So I'm not going to deep dive into each and every platform today. But we will mention some salient points about each of them. So if we start, and of course, this isn't the whole stack. So what's missing from this particular slide is the whole discussion about unified computing system, the UCS platform itself. I'll cover that later on. So this represents the infrastructure piece as far as switching technology is concerned. So Ethernet, hypervised switching, routing, and fiber channel switching as well, the MDS product range. Let's start with the Nexus 1000V. And I'll assume nothing, so maybe some of you are familiar with the Nexus 1000Vs, maybe some of you are not. It's essentially a hypervisor switch, a software switch. So it's really a virtual machine, or it can be put on an appliance. The concept there is it replaces the virtual switch in an ESX vSphere environment. So the aim there is to get it back to, as much as possible, a regular layer 2 access level switch that traditional networking admins are used to seeing when they connect their servers up to it, which was somewhat taken away or missed somehow when we went to a hypervisor environment with the vSwitch. It was great concept, didn't have all the functionality that we're used to seeing with a regular edge switch. So that was one of the reasons to bring this back. It runs on the same code that all of the rest of the Nexus platforms run on, NXOS. In fact, NXOS runs on all of our infrastructure platforms, whether it's a fiber channel MDS switch, whether it's a unified compute server, or any of the Nexus products, they all run NXOS. And they could all be managed by the same management tool, Data Center Network Manager. Okay, so very successful product. It is a virtual switch. It has two elements. There's a virtual supervisor module, as you'd expect to see in a regular Catalyst or Nexus switch, a supervisor module. You'd have two for HA, you'd have two of these for HA. Then the other portion of that is a virtual line card. So instead of having a real line card in a real chassis, you'd have a virtual line card and that would sit on the ESX host itself. So it's a distributed switch. And that's the model we're trying to get back to. There's lots of benefits and features in the Nexus 1000V. To me, the two major benefits and advancements over a V-switch, for example, would be the fact that it's capable, when the virtual machine does a live migration between hosts, which is either by design or it's happening automatically with dynamic resource management or HA, those VMs are moving around the cluster. What doesn't move, unless you've got something like a Nexus 1000V switch in your implementation, is the port profiles and policies that were set to that port for that VM. So you had to manually do that on each host, and that's prone for error. With the Nexus 1000V, we've called it VN link, which is a marketing term, but essentially what that means is the port profile, or the characteristics, the statistics, the counters, the VLAN information, the security information, quality of service, everything that's been carefully configured for that port moves dynamically when the VM moves as well. So wherever that VM moves and ends up in the cluster, the port profile moves as well. Because that's a very important point that was missing in the virtual switch. For me, the other important point really is that orange dotted line up there. I mean, it raises the view and the management and controllability of that virtualized switch up into the hypervisor layer, which was something that was missing, in my view, when the vSwitch in a hypervisor environment was introduced. It was managed by this server admin, which was great. It gave them autonomy, it gave them flexibility. They didn't necessarily have to speak to the networking team. But there were problems there when you need to speak to a networking team or a network admin about some network issues. Had no visibility of it. There might be one port there physically attaching to the host. There may be many virtual servers or many, many virtual desktops behind that one port. Had no visibility of that whatsoever. The Nexus 1000V gives them that visibility back. So yes, it looks and feels like a regular Cisco switch. It can connect to any other switch. It runs a command line interface, which it is NXOS. So it's the same as being on a Nexus 7000 or a Nexus 5000. It's very, very similar to iOS if you're used to Catalyst environment. So there's two really key benefits to having a Nexus 1000V as your software switch. Visibility into the hypervisor switch and the port profile mobility. The flexibility to capture all that important configuration data. When that VM moves, its port moves with it, and all its port profile statistics move with it to the next host. Okay. On from there, it's not just about taking the port profile. What else? You know, we need to be mindful of security. So we'll talk in a moment about the virtual security gateway and application acceleration services such as WAS. There's a virtual version of that as well. Okay. This is the Nexus 1010. Essentially, it's built out of our UCS C200 range. It's a Cisco server. But we've made an appliance out of this, and we've put a hypervisor component on there. And really, this is aimed at organizations that want a clear demarcation between where they deploy a switch versus a server. Now, the virtual switch, the Nexus 1000V, can be deployed by a server admin. In fact, it needs to be. They need to load the software. They need to configure it to some degree. IP address, gateway, mask, et cetera, but then they can give that back to the network admin for the rest of the configuration, the rest of the management and ownership of that switch. If that's not enough and the networking team want ownership of that, maybe from a cost perspective, a budgetary perspective, they can put it on an appliance, this 1010. That's really what this is for. Our customers ask for this. Yeah? We like the Nexus 1000V, but we don't want to put it as a virtual machine on the hypervisor. We want it somewhere else. Well, it's still virtual up here, but it's on an appliance. So for me, I can give that to a network guy, he can put it in his network rack. It's that simple. It's a demarcation point. That's really the main focus of this product. It's still a virtual supervisor module. There's still virtual line cards. It's just sitting somewhere else in the data center. So it's an ownership thing. So we can put multiple virtual supervisor modules on this platform as an appliance. We can put other things as well. Network analysis module, we'll start to see other devices, virtual devices coming on here, like the virtual WAN acceleration service, WAS, and others as well as we go forward. So be mindful of this. The Nexus 1010 is an appliance for virtual switching type of technology, analysis modules, WAS, et cetera, as they become virtualized. I mentioned security. So now we've got a different paradigm as far as switching characteristics is concerned. We had lots of traditional northbound, southbound traffic before. Easy to manage, easy to secure. Now we've got VMs talking to VMs. We've got lots of east to west traffic. So it's a different traffic pattern to capture. Mindful of this, Cisco has introduced a virtual security gateway. So it's another virtual appliance or virtual entity. It can be loaded onto the hypervisor. It integrates with Virtual Center. You can manage it via Virtual Center using the virtual network management controller, which is part and parcel of the same platform. So we'd set up the configurations, we'd set up security zones. As soon as a virtual machine is instantiated, it's been designed, configured to join a certain zone. As soon as it comes online, it's part of that security gateway zone. So traffic traversing to or from that VM will or won't be directed via the virtual security gateway based on its configuration. And we're allowing that redirection to happen with this concept down the bottom of the slide there called vPath, which is part and parcel of a Nexus 1000V switch. So a really important point here is you need a Nexus 1000V switch to get the virtual security gateway. It's kind of all wrapped up together. So the redirection of how do I get my interesting traffic to the gateway to be looked at from a firewall perspective, that's the vPath piece there. It's redirecting that traffic back out. But then it's smart enough to offload that. It sees another stream up from the same server, the same address. It won't necessarily send it off to the gateway. It'll offload that to the switch. vPath knows how to pass that traffic on without interaction with the virtual gateway. So it's acceleration as well. So there's another couple of important components to the whole Nexus 1000V hypervisor switching discussion there. Watch out for more to come, virtual WAS, etc., network analysis modules, and so on. Moving on to physical kit, although where's the physical and virtual barrier these days? Those lines kind of blur because there's virtualization through all of our product ranges. And virtualization means different things to different people. But when we look at the Nexus 5000 platform, you almost always end up talking about the Nexus 5000 and 2000 in the same discussion. And again, I won't assume that you all know about the 5000 or 2000. The Nexus 5000 was launched 3 years ago, 2008, as the first unified switch on the market. So straight away it was capable of, yes, gig Ethernet for sure, 10 gig Ethernet, but also that enhanced type of data center bridging, that enhanced Ethernet which allows for lossy and lossless traffic. And once you have that kind of platform capability, you can start to put other types of traffic over that link, such as fiber channel over Ethernet, which is already standardized. Now you have the capability of a unified switch. Now we can start to really talk about consolidation. Yeah? Now that's a long journey. I don't want to fool anyone that we're selling this today and everyone's switching from fiber channel to Ethernet. It's going to be a phased approach. But we're having lots of discussions with lots of customers about where they should integrate some level of consolidation. At the edge, do they take it up to the aggregation? Because we're now releasing features and functionality in the 7K, in the MDS to do that. And I'll touch on that as we go through the deck. So the 5000, 2000, yes, a very capable gig and 10 gig switch. It also has a lot more capability. It's a unified switch as well. So instead of a server talking northbound to Fabric A Nexus 5K for its 10 gig connection and another one for its Fabric B, and then two SAN A and SAN B fiber channel switches, we can consolidate them into one first bump in the wire switch. And we've been able to do that for 3 years. The first product did that. We've since enhanced that and brought out other features and functionality to the next iteration of the 5000. So again, quick look through this. I'm not going to dwell too much on the speeds and feeds here. This is the current shipping version of the 5000, 5500. Two flavors, 48 port and a 96 port. So the model numbers actually mean something. So 5548, it's got 48 ports on it, or capability to have. If there's a 5596, it can have 96 ports on it, up to. What you do with those ports really much now comes down to licensing. In other words, for this product, the first 32 ports are fixed. I can have another module. I can put another module of Ethernet-only ports in there, fiber channel-only ports in there, Or why not just put a unified port module in there, because they can be anything. I need to configure the port and put the right optic in there, but yes, it can be a gigi, a 10 gigi, data center bridging class of optic, which allows for lossless and lossy types of traffic, or just a native fiber channel optic. In other words, if you're not quite sold on this consolidation piece of networking, of unified switching, maybe you've got aims to go down that road, but you're not quite ready yet as a customer, this platform gives you the best choice, because it can be anything. It can be a fiber channel switch, it could be 96 ports of just native fiber channel switching, or it can be all of the others as well, or variants of. So we'll license this by 8 port groups. So you'll license for Fcoe or fiber channel native traffic. 10 gigi and gigi is free, it's a standard offering. Okay, so that's where we are with the Nexus 5000. We've enhanced it, brought out another couple of models to enhance the range. You can get different modules here to plug into the empty slots. So the 2 items on the left of the screen there were the initial switches, 5020, 5010, a 1 rack unit switch and a 2 rack unit switch. We've kind of replaced them there, they've been surpassed. So the later 2 products, the 5548 and the 5596, are the follow-on products. Much more capable. Those are the current shipping products. If you want 10 gig Ethernet, fiber channel native ports, or Fcoe, those products have the capability to support that. You just turn the license on a given port. There was also a requirement, the initial shipping products didn't support layer 3 routing. The requests come back that we'd like to see that feature on the Nexus 5000 layer. Some people want to do layer 3 at the edge. Some people want a small environment with core as the Nexus 5000. As you'll see in a moment, the Nexus 5000 can scale very, very well, very capably with the Nexus 2000. So layer 3 was introduced onto both of these platforms. Yeah? In the shape of a daughter card on the 5548, you swap that out or add that in. Or a module, plug-in module, up to 3 modules on the 5596. So how much routing capability do you want depends on the standard offering, or an enterprise license for routing gives you much more capability. And that's the 5596. Standard is 48 ports. You can put in modules as you see fit of whichever type you see fit, with a layer 3 module or additional 10 gigi ports, which support gigi as well, or unified port module would be my choice, because it can be anything. Native fiber channel, gigi, 10 gigi, data center bridging class of ports. Very, very flexible model. Of course, around that switch was an ecosystem of supporting products from different vendors. And I'm talking here not just about storage vendors supporting unified switching and reselling unified switching, but I'm talking about storage vendors having a unified port adapter or target adapter in their array. So you can take 10 gigi from the server through the switching environment all the way to the array at 10 gig. And the benefits thereof about throughput, bandwidth capabilities, etc. To support that, we seeded the technology to various traditional fiber channel adapter companies like QLogic, Emulex. We went to Intel with this, and they used our technology on their first generation cards. And then they've since surpassed that and come out with generation 2 cards, and generation 3 cards are now on the market. So they're much more efficient from a power perspective, much more capable as to what they can do. You can license them to do different things. Today, if you buy a NIC card from QLogic or Emulex, just for NIC or iSCSI capabilities, it's the same ASIC as the CNA would be, the converged network adapter for doing fiber channel over Ethernet. So they've crossed the bridge into a bigger NIC space, and the traditional NIC vendors, Intel, Broadcom, etc., are also crossing the bridge into the fiber channel space, where there were traditional niche players for host bus adapters for fiber channel connectivity. So there's a point I'm trying to make is that infrastructure, an ecosystem building along with what we introduced to support that. It's not just Cisco talking about unified switching. Just a couple of points there on our layer 3 capability on both the new platforms. They both have that capability, either in a daughter card at the top there for the smaller product, the 1U chassis, or a plug-in module, up to 3 of them for the 2 rack unit device, the 5596. So again, huge amounts of scale, huge amounts of capability and flexibility in that platform. Which brings me on to the Nexus 2000, which is a great selling story. I mean, most customers that go down the Nexus 5000 route almost certainly, depending on the size, end up with Nexus 2000s. It makes a lot of sense. What is it? It's otherwise known as a FEX, or a fabric extender, which really kind of spells it out. It extends the switching ports from the parent switch to the top of the rack, wherever that fabric extender is. So if you imagine a chassis-based Catalyst 6500 or Nexus 7000, you took a line card out and you put that at the top of the racks where you needed connectivity from your servers, that's the concept. So there's no switching performed on this device. All the switching is handled back at the parent switch, be it that a Nexus 5000 or a Nexus 7000, yeah? So what's the benefit there? Well, I can have my best of breed, best of design, top of rack cabling, which is much more neat and much more structured, but I can have my end of row management approach. So it's the best of both worlds. So all of the management, code loading, I'm configuring the switch, it's all done on the Nexus 5000 or 7000, it's the parent switch. If I have 16 or 20 fabric extenders hanging off of that, that's pushed out to the line cards. So you put these at the top of every rack or adjacent rack, depending on your density of the rack. Good cable management, short cables, they can be twin-ax copper, 10 gig cables, so very low cost, low power, low wattage. And then some uplinks ×4 to the end of row, multi-mode, SFP plus optics. So best of both breeds. I manage one point at the end of the row. By default, then I'm managing the whole row. But my cable management is not all going back to the end of row, which could be kind of messy. So fabric extension, very, very popular, very successful. There's various different flavors. There's a 48-port GigE. There's a 32-port GigE stroke 10 GigE module as well, which also supports fiber channel over Ethernet. So I can start to fan in my multiple 10 gig edge servers into a top of rack fabric extender. Doesn't matter if I'm talking to my NAS device, I want an IP storage network, iSCSI. I might even have a fiber channel target at the end of my network. I can still go in through the same product with the same optic, with the same cable. Right, wire it once, push many different protocols over it. So that's the fabric extender. There's a graphical representation of what that would look like. So yes, one parent switch manages it, but it's as many as you like to have cable perspective platforms at the top of each rack for ease of cable management. I want to upgrade code to this. I don't upgrade code to it. I upgrade the code to the parent switch. So that's the design. That's the concept there. Takes us on to our Nexus 7000 platform. So arguably the aggregation core platform, although some people choose to use this as an access device as well, a large access device. And you can certainly hang fabric extenders off of this as well. So the Nexus 7000's been out for 4+ years now. Very successful platform, multi-different options with that platform size now, as we'll go through. Designed from the ground up to aid a virtualized network. We're talking about cloud infrastructure here. What are the product enablers under that cloud? It's this type of platform, for sure, with the capability of virtual device context for partitioning up the chassis, if you will, for different layers, layer 2, layer 3, on the same chassis, maybe different departmental or operational boundaries that you might want to choose to carve up that platform. Highly available as you expect, double soups, multiple fabric modules in the back for high availability. Investment protection often comes up. Yes, it's a GigE and 10 GigE capable switch today. We are launching 40 gig line cards and 100 gig line cards, and we'll go through in a moment how we get to that. Is that a forklift upgrade? No, it isn't. The box will also support, as of the end of this month with our next major code release on this platform, the Fcoe line card, which goes back to the discussion I had earlier about converged networking. Where does the rubber meet the road as far as my fiber channel traffic to my traditional layer 2 network? And where can I consolidate those? Where can I merge that traffic? Today, or up to this point, it's been a Nexus 5000 class of switch. From then on, it was traditional layer 2 fiber channel native. Now we're starting to see with the implementation of the new support for Fcoe in this platform, and at the same time, the NDS platform, our fiber channel switching platform, we can take the traffic where we want, to that next hop, or multiple hops. And that's getting a lot of attention, and a lot of people are asking lots of questions about, well, how do we manage that? Well, who owns the port? You know, that's going to be the next round of discussions that I'm going to have. The technology's there to do it. The argument always becomes more political. But there's good mechanisms to drill down as to who has ownership of a given port. How do we give certain quality of service to the traffic that's within it? What platforms have we got in place to secure that types of management? So the Nexus 7000, very capable. We started off with the 7010 10 slot, and the 7018, the 18 slot for the larger environments. And then we're just about to introduce the 9-slot chassis, which often gets some questions about, well, why 9 slots? We've already got a 10-slot chassis out. What's the benefit of a 9-slot? Well, it's designed to mount on 2 pillars, front posts. It's the same size as a Catalyst 6500, so it's about that size. It's got 9 slots, but it's 14 rack units high. So we've completely repackaged the 7010. That will suit some folks. Other people see the 7010 as a better choice. So it's all about choice, and we're looking at other form factors for other reasons as well. So be mindful of the 3 different types of 7000 platform that are out there today. Yes, there's many different line cards. You can have lots of flavors of payload cards in the box. I'm not going to go through all of those today, but for sure there are gigi options, 10 gigi options, full line rate options, Fcoe options. They are just layer 2 cards for a large layer 2 access environment. There are cards that would suit a layer 3 environment better. And there's a mixture of cards coming out that would cross over the chasm there. So the next iteration of card will be an F2 line card. So very, very capable layer 2 card, which has some layer 3 capabilities as well. So it's all about giving more choice for the deployment design. All of them will have 2 supervisors and at least 2 fabric modules, which is the switching ASIC architecture around the back of the box, where the frames are switched by. You can add up to 5 of those, as we'll go through and see. So the Nexus 7010, they'll all work in a similar fashion, but the line card packages will have certain amount of bandwidth capability at the front ports, at the line card slot level. We get to that level by adding 1 or more fabric cards. Yeah? So in the initial release of Fabric module, the first ASICs we had supported 46 gigabits per second at each line card slot. Yeah, so if you had an 80 gig line card, you need 2 of those to be fully full line rate. You add more of those for redundancy, or if you need to add more cards that have capability of using more bandwidth. So initially they weren't, but now we've released a line rate 10 gig card, which will need more than 80 gig at the line card slot, right? So you add more fabric cards to supply your need of switching. And you can add up to 5 to a maximum on that particular design, the Fabric 1 design, of 230 gigabits per second per line card slot. So we see that progressing. We've already got the next ASICs ready to ship. In fact, the next platform, the 7009, will probably be released with the next Fabric 2 design of card. In other words, it supports more bandwidth for line card slot. So as the newer line cards come on with more capability, we can swap the Fabric cards out, put in a Fabric 2 module. It's got more horsepower, basically. It supplies more bandwidth per line card slot. So as the card technology on the left, the payloads technologies on the left increase, we supply more bandwidth at the backplane by the introduction of different types of fabric card. And on it goes up to 550 gigabits per second per slot. So, you know, lots of speeds and feeds here, but it's a very capable product. It's future-proofed. Investment protection, I mentioned earlier on, this is how we do it. We don't ask you to lift that box up and put another one in because we've introduced new hardware. We think about the long term. I think Cisco's shown a great heritage in that with the Catalyst devices. The MDS platform has been out since 2002 and can do most of the things we've been talking about already today, up into and including 10 gig Ethernet for Fcoe traffic. So we've got that kind of model in place. We've had for many years. Others do it a different way, and some things fit different organizations differently. Been shipping now for about 6-7 months, the F1 series line card, really aimed at the layer 2 environment, very capable layer 2 card, 10 gig line rate ports. Has the capability on it, as the hardware, to be a fully functional fiber channel forwarder. What does that mean? When we turn the license on later this month to introduce Fcoe, I can then take my Fcoe hop up to the next logical point, the aggregation layer, or 7000. Where I go from then is up to where does it best fit? What are my goals? What do my end designs look like? Do I take it off to the side there to my regular SAN A and SAN B? Do I take it up to the core? Do I take it off to the side where there's a new array that supports Fcoe targets? So that all things now become possible. But this is the hardware that will give that. Yeah? And later on in the year, we'll have an F2 card. Again, similar market is aimed at the layer 2 space, but also has layer 3 capabilities. So depending on your layer 3 desires or your throughput, you might choose just to put F2 cards in there. Obviously, the M series of cards continues as well. They have more feature functionality on them because there's only so much real estate on the card. Which way do we go with that? You can put too many things on a card and it doesn't do them all particularly well, or you focus a particular card for a certain task and it does that very, very well. So we've got different flavors of card to suit different design requirements. This is also the card that will support Trill when it's a standard, but already it supports FabricPath, which is Cisco's first implementation of a layer 2 multipath software. So this is the card that will deploy that as well. I've mentioned this already. Fabric extension supported on the Nexus 7000. If you have 7000s at the edge and it makes sense to extend that parent switch to the top of every rack or however many racks you desire, the Fabric extender can feed back into this platform also. So you have the same capability there as we had before. If you're not aware of it already, virtual port channel was a functionality that we introduced with the Nexus to enable active-active switching on multipaths to two different devices. So as far as a downstream switch or host was concerned, it was logically talking to one switch upstream, but really it was going to two devices. The benefit there, in a normal spanning tree environment, one of those ports will be blocked, virtual port channel, they're both active. Okay? So obvious benefits to that scenario. Spanning tree protocol is still running in the background, but virtual port channeling is enabling you to have much more higher availability with active-active bandwidth on both ports. FabricPath kind of is the next logical step from that. Yeah, it's Cisco's first introduction of a layer 2 multipathing software. We will support Trill when it's standardized, and it will be on the same platform. And you can support Trill or FabricPath. We'd suggest that FabricPath has got a little bit extra in there. So we're doing things slightly different from the Trill standard, but we'll support both. But essentially, we're offering some of the layer 3 characteristics on a layer 2 card. So it's using a routing protocol, ISIS. It's using MAC encapsulation, so it has a switch ID and a port ID encapsulated at the top of the frame. So we can now move that frame onto a switch where it needs to go for its destination, rather than go up to a layer 3 level. So some of the benefits there have been called for many years in the switching environment. Can we get away from spanning tree, please? It's a huge thing to manage. Well, this is where layer 2 multipathing is going. That's what Trill is all about, which the standards body is working to standardize. We've released this already back in late last year, which is our first implementation of that, layer 2 multipathing. We've called it FabricPath. Kind of similar discussion, but for different reasons, is the feature of OTV, or Overlay Transport Virtualization. So where would you use this? Typically, this is deployed for data center interconnects requirements. So customers looking to migrate services to another site, looking for a large flat layer 2 environment to move virtual machines around the cloud. So a geographically distributed cluster. So I need a layer 2 adjacencies over my 2 geographically dispersed data centers. OTV can allow that to happen. So I talked about FabricPath just now as a MAC in MAC encapsulation. OTV is a MAC in IP encapsulation. So we're encapsulating the MAC frame into an IP datagram and getting it to the other device and the other Nexus on the other site. So to do this, you need the code for OTV, the license for that. You need a virtual device context on each 7000. And there's literally about 5 lines of configuration to configure OTV. So great for those types of deployments. Large layer 2, geographically dispersed adjacencies. I'm not going to spend too long on the MDS, but this deserves a mention because it's part of the layer 2, sorry, it's part of the infrastructure switching family as far as Cisco is concerned. Yes, we don't make storage devices, but these platforms are sold by our storage vendor partners. Okay, so we know about the storage networking environment very, very well. We're quite capable of having that discussion with the customer. And as they start to move towards a converged management team, a converged administration team, can we overlay our fiber channel SAN, which is our crown jewels of applications, our tier 1 applications sit on a fiber channel SAN? How do I implement that onto a layer 2 network and not go down a big rat hole, or have merged fabrics, or have security concerns, or have administration issues where the LAN admin shuts the fiber channel port? So it might be common in a layer 2 environment, it's definitely not common in the fiber channel environment. So there's all those sort of caveats and concerns we built into a design session, which is it's an hour and a half session on its own. But that's this kind of discussions we're having because we have the capability not only to put the line card that has a fiber channel forwarder capacity into a Nexus, whether that's a 5000 or a Nexus 7000. But we also have the same capability in the MDS chassis, in the MDS director platforms. So it can become a fully functional Fcoe capable switch. Receives 10 gig traffic. That's how I get my fiber channel traffic to my SAN. Why do that over an 8 gig link or a bunch of 8 gig interswitch links? Because the throughput of 10 gig gives a 50% uplift on throughput over that of 8 gig. Yeah? The encoding of 8 gig is less capable or less throughput capable than that of 10 gig. It uses 8-bit, 10-bit encoding versus 64, 66-bit encoding that 10 gig Ethernet uses. And the baud rate's different. So in other words, the throughput is higher. It only sounds like 2 gig, but you're getting 50% uplift on your throughput. So from an administrator's perspective, if I'm putting less links into my interswitch design, then I'm freeing up ports for other things like storage traffic or server traffic, etc. It's a value proposition. So the MDS line continues for our customers that want to continue on to just native fiber channel. 8 gig, 16 gig is coming as well. We are continuing on to support that, but we do see a coming together of those two worlds in a very phased approach. And that's right where we are now. The picture on the right is phase 2, that's where we are now. On the left, we've been there since the introduction of the Nexus 5000. That was the unified switch. That first bump in the wire that converged network adapter host saw was a unified switch. From then on, it was traditional layer 2 Ethernet, traditional native fiber channel, A and B. Well now, with the picture on the right, we can start to talk about how do we continue that discussion at 10 gig with my Fcoe payload in there? And how do I separate that from my layer 2 traffic? Yeah? And what about spanning tree and fabric path and virtual port channels? There's considerations about all of those, and we need to be mindful of those. We haven't got time to go into the caveats there today, but we've thought about that as well. So we need to be mindful of literally overlaying a SAN A and a SAN B onto a layer 2 cloud. You can do it. We need to be mindful of how we do that and not go down a big rat hole. But that's really where we are today. So the discussion continues on. Where do we take Fcoe, that next hop up to the aggregation layer, or straight out to a SAN, but over 10 gig E rather than native fiber channel? That's where it's taken up a lot of my time talking to customers about unified switching. That's where we are today. And you can see the potential implementation there and a data center design, whether it's a UCS discussion with unified computing, a traditional rack or blade server environment. We can have Fcoe coming from a traditional blade server. Our UCS is by default supporting of Fcoe. It's all unified anyway. Or a traditional rack mount with a converged network adapter in it will get you up to a top of rack unified switch, like a 5000. So depending on where you're coming from, what kind of platforms, we generally have a solution for that. Which leads me into the last 10, 15 minutes, and I need to spend at least that on unified computing system. So the UCS is Cisco's introduction of a compute platform. Yeah, back in 2009, we introduced this. In fact, I think I've got where we were in the roadmap. So 2008, we introduced early 2008, the Nexus 7000, with all of its capability to support infrastructure type services that we've been hearing about this morning. Yeah, the product enablers underneath the cloud and infrastructure as a service, public cloud, private clouds, etc., are things like the types of features that I've mentioned in the platform so far. Later on that year, we introduced that first unified switch, the Nexus 5000, and all of its capabilities, unified switching. Nexus 1000 with VN Link, so the flexibility to port profiles across when that live migration of a VM happened as well. Very important to move the port characteristics and the configuration of that with the virtual machine, introduced in 2008. And then the fabric extender technology came along a little after the Nexus 5000 in 2009. Then we introduced later on in the first half of that year, the unified compute platform. So it was a big shock in the industry, I think. Why is Cisco introducing a compute platform? Are they just going to compete on a product level, blade per blade per blade, with our other vendors out there with compute blade systems? So that's gone through a big evolution in the last 10 years, the way they've packaged servers. They put the rack servers on their side, they put them into a chassis, they put the switches that they would have connected to anyway into the chassis, the layer 2 Ethernet switches, the fiber channel switches ×2. It needed a management piece in there as well, and it needed a top of rack management piece. So we've added lots of points of management by packaging it better, but they've got more server capacity, if you like, in the footprint of a rack. So some benefits for sure, but it's not taken away any points of management, it's probably added to them. As we moved into that technology, we introduced a completely different paradigm to this. We took away the management server and embedded it into what we call fabric interconnects. And as you'll see as we go through, they look quite a lot like a Nexus 5000. They kind of come from the same stable. Now, I'll probably get shot for calling it a Nexus 5000, but the platform is very, very similar. It has an embedded management piece in the fabric interconnect, which is the single pane of glass, the single management point for an administrator to manage the servers, the mezzanine cards, the firmware, the service profiles, the events, switches, etc. One pane of glass, different tabs, one pane of glass. It's all done from that top of rack fabric management piece there. So with that in mind, if that's doing the management piece, where does the switching happen? So we took the switches away from the chassis and did all the switching at the parent switch. Now, I talked about that earlier with the Nexus 5000 discussion. The switching is done at the parent switch level. It's the same thing here. So if we've got switching done at the top of the node, and a node could be a pair of fabric interconnects with one chassis, or architecturally up to 40 chassis, it's a node. Now, they might be in different racks, but there's one pair of fabric interconnects for high availability, and they support a number of chassis. You add more capacity as you need it. How many does the solution need to fix the requirement for compute, networking, and bandwidth, etc.? So we've done all the switching in the fabric interconnect, so why have the switches inside the chassis at all? So we've optimized the switching, we've optimized the switching on board as well. If this is a hypervisor environment, we bundle this with Nexus 1000V on the blades, so each of those blades could be running ESX. They'd have a management virtual switch inside each of the ESX environments, a line card in there. We're taking away the fiber channel switches ×2, the Ethernet switches ×2 from the chassis. All we have in there is the concept of what I discussed with the 5000, 2000, that concept of that remote line card switching. It's not a switch, it's just an extension of ports. That's all it is. So these blue boxes there on the right-hand side, they're actually fabric extenders. We call them something slightly different, I/O modules, but essentially it's the same thing. So it's all about extending the switching ports down into the chassis. And that's all that goes on there. The switching is done back up at the parent switch, that fabric interconnect. So we have a neatly packaged solution. There's a lot less going on in there as far as lights out management, lots of GigE ports, fiber channel ports, switches, management pieces. It's a lot less going on in there. We can manage multiple chassis. Northbound of that gets us back to our regular discussion point of regular Ethernet, regular fiber channel, but then we are looking to extend the fiber channel piece as well. So how do we go northbound of this management point to extend our FCE traffic onto another switch, maybe onto a fiber channel or Ethernet target? So that will be coming out later this year as well. The components here, I'm not going to spend too much time on the components. Yes, there's components in there. Of course there are. Underneath every cloud, there's some physical things, and they run the bits that we all need to run in an infrastructure as a service environment. There are fabric interconnects at the top. There are fabric extenders underneath that. In every chassis is a fabric extender ×2. The chassis itself is a chassis. It's got management capability, but it's all driven from the management embedded into the fabric interconnect. So I don't manage multiple different things. I manage one place. Yes, of course, we've got server blades and different adapters, mezzanine cards from different vendors, including ourselves, the virtual interface card. What it looks like from the front, more interesting what it looks like from the back, because there's less going on, there's less cables. The only cables really are the bandwidth cables for the I/O modules, the fabric extenders, 1 to 4, that's it, in each I/O module. Of course, you'd have some power adapters in the bottom there as well, but that's it. So there's much less going on than the real estate, so it's easier to cool it as well, much more efficient. Yes, different blades, we have different flavors for different types of solutions. I'm not going to go into these in any great detail, but they are different blades. They support different types of CPUs, different amount of cores, larger or smaller memory footprints, up to 48 DIMMs in one of our larger blades. So great for virtualization in a cloud, great for VDI deployments. If it's a hypervised environment, we'll have that Nexus 1000V management point, but we can even take that away as well. If it's a bare metal implementation, the only management for switching would be up at that fabric interconnect level. So we're taking away those layers of management points. That's the idea. And just to finish up on something called service profiles, another very important innovation here is the idea or the capability to give a personality to a server. When you build a server, if it's a web server or an email server or a database server, it has different characteristics from each other. different bias levels, different firmware settings on the adapter cards, etc. Once that's been configured, it's in software. It's a service profile. If I want 10 of those, I'll make a template out of that and roll it out 10 times, 15 times, etc. I can also move it. If I have an issue with the server blade, it's the hardware, it's abstracted. That profile is abstracted. I can disassociate with that blade and associate with another one. So portability, or stateless computing, as it states up there, is absolutely a reality. I can disassociate from one blade, move it onto another blade in the same chassis, a different chassis, anywhere else in the node. That node being how many chassis does that pair of fabric interconnects actually own. And I run out of capacity there, I add another chassis, auto-discovers, it just sees more resource, puts it into the resource pool. So service profiles is a really powerful tool. From a management perspective, we're not trying to boil the oceans here, contrary to some other opinions. So yes, we have a great tool in the UCS manager embedded in the fabric interconnects. There's always two, one in an active-passive situation where the database is always backed up to the other fabric interconnects. You do have a failure. But for those other tools that need to perform some of the things we're hearing about today, cloud orchestration, service catalogs, other tools to manipulate VLANs, how do I create a LUN on a storage device? All of those cloud elements that you'll hear some of my colleagues talk about today, Lineside, NewScale, some of those other products, we have open technology to allow those other companies, including our own tools, to manipulate, drill down into the fabric interconnect and manipulate the whole environment. Whether it's a VLAN statistic, firmware settings, what kind of server I need, do I need to connect my SAN, boot from SAN, how do I connect and drill through and configure my boot LUNs? All of that is allowed and open to the upper management suite of framework managers, such as Compute Associates, such as EMC's Ionic suite, to name just a few, BMC, et cetera, et cetera. And you'll hear more about that from my colleagues today as we go through. So with that, I think we're right on time. From an infrastructure perspective, the building blocks are there already. Whether it's a layer 2, fiber channel, unified environment, we have the MDS and the Nexus platforms all ready to go, already virtualizing to a large degree anyway. Where do people want to take that for the next step? It's a very capable set of platforms for that environment. And of course, as we talk about computing, the unified computing system allows all of those things, plus the compute. So by design, it's already unified switching capable. And I'll leave you with that thought, ladies and gentlemen, and thank you very much for your time. I'll take any questions. And I'll be around through lunch and after lunch. If you have a question, Chris.
VSG, is it part of TrustSec? Does it support TrustSec?
I'm not sure if it supports TrustSec yet. I think that might be on the roadmap, but I'll check into that and I'll let you know. Yeah. The 7,000 is, so yeah, I think we're going to go in that direction. Makes sense to do that? Yeah, I'll check. Okay. Thank you very much for your time.